Your API crashes every 30 minutes with killed, and you've been blaming your code. But the real culprit? You set workers, 4 on a 512 MB instance, and the OOM killer did the math for you. Let's break down FastAPI Cloud, official deployment platform, how it works, and the exact mistake behind that failure. FastAPI Cloud is a valet parking service for your API. You hand over your code, they deploy it, and when traffic spikes, they autoscale. You never worry about the parking lot. Before FastAPI Cloud, deploying a Python API meant choosing between a VPS or a container platform. You spent more time on infrastructure than on your actual code. FastAPI Cloud removes that entirely. Here's a minimal FastAPI app ready for FastAPI Cloud. It has one route that returns a JSON message. You'll deploy this with a single CLI command. This is the entire app. Save it as main, py, then run FastAPI Cloud deploy from your terminal. That's it. The CLI handles packaging your code, uploading it, and provisioning infrastructure. Under the hood, it builds a Docker image, starts a load balancer, and sets up HTTPS automatically. Run these commands in order. After deploy, you'll get a URL like https://your app, FastAPI Cloud. Always test locally with Unicorn first. FastAPI Cloud uses a YAML config file to control deployment behavior. You can set the number of instances, memory per instance, environment variables, and more. The default is fine for hobby projects, but production needs more. Here's a production config for a checkout service. It scales between 2 and 10 instances, each with 1 GB memory. Environment variables hold secrets. The health check endpoint is called every 30 seconds. FastAPI Cloud instances are ephemeral. Don't store session data or files locally. Use a managed database with an async connection pool to avoid exhausting connections. This code creates a connection pool on startup and reuses it across requests. Don't use SQLite. The file system is ephemeral and data will be lost. FastAPI Cloud provides basic monitoring. For detailed observability, send structured JSON logs to stdout and pipe them to an external service like Logtail or Grafana Loki. Use structlog to output JSON. The platform captures stdout and stdir. Add a health endpoint that checks critical dependencies so FastAPI Cloud can restart failing instances. FastAPI Cloud is for the 80% of APIs that are simple and stateless. If you need GPUs, system packages, compliance, or advanced networking, look elsewhere. This is the same issue we highlighted at the start. Here's exactly why that happened. The team set workers, 4 in their config, assuming more workers means more throughput. But each worker consumed ~180 MB, totaling 720 MB, exceeding the 512 MB limit. The kernel OOM killer terminated the process. The team set workers, 4 in FastAPI Cloud. YAML, causing each worker to consume ~180 MB under load, totaling 720 MB and exceeding the 512 MB instance memory, which triggered the OOM killer. The fix was to remove the explicit workers override and let FastAPI Cloud auto-size. For high-traffic endpoints, they used a larger instance with 2 GB memory and set workers, 4 explicitly. Always match worker count to available memory. This is the exact mistake from the incident. Setting workers, 4 on a 512 MB instance, causes OOM kills. Always measure per worker memory consumption and set workers accordingly. If your requirements.txt is missing a dependency, the build will succeed but the app will crash on the first request. Always run pip install requirements.txt in a clean environment before deploying. Scaling up takes 30-60 seconds. If you get a sudden traffic spike, early requests will timeout. Set min instances to handle your baseline traffic to avoid cold starts. The FastAPI Cloud CLI package and platform are still evolving. As of early 2025, the CLI version 05x uses a YAML config with runtime, Python 3.11. Future versions may require Python 3.12 or change the config schema. Always pin your CLI version in CI/CD and check the changelog before upgrading. FastAPI Cloud can terminate instances at any time, e.g., during scaling or health check failures. Your app should handle SIGTERM to close database connections and finish in-flight requests. Add a shutdown handler that waits for pending tasks. If your requirements.txt includes large packages, e.g., pandas, numpy, the build may exceed the default 10-minute timeout, causing a silent failure. Monitor build logs for timeout errors and consider splitting dependencies or using a pre-built wheel. FastAPI Cloud does not expose a configurable build timeout as of this writing. Use these commands to debug. Check logs for memory-related errors. Monitor the dashboard for CPU memory spikes. Increase memory in config or optimize code. Let's run through some common interview questions. How does FastAPI Cloud handle concurrency? Single unicorn worker with a sync event loop. Use async libraries to avoid blocking. When choose FastAPI Cloud over Cloud Run, for zero config, no advanced networking needed. Cloud Run for compliance, GPU, GCP integration. What happens on OOM'd? Instance killed and restarted. Detect via memory metric spike. Mitigate with higher memory or optimization. And a few frequently asked questions. How to deploy? Install CLI, login, deploy. App must listen on port. Difference from Heroku? Purpose-built for FastAPI, better auto-scaling, lower latency. How to set end vars in FastAPI Cloud, YAML end section. Secrets encrypted. To recap, FastAPI Cloud is great for stateless APIs. Always use async database drivers, set min instances for baseline traffic, and match worker count to available memory. Avoid it if you need GPUs, system packages, or compliance. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.